The reason why for question 1 over here, part A, un is equal to this is correct. The reason why we replace the n over here with 11 is because you want to multiply it by 1.05 10 times. 2005 to 2015 is 10 years difference. You multiply it by 1.05 10 times to reflect how much it's increased, because it increases 1.05. It's 5% increase every single year. 10 years have passed, has to be this. If you were to replace this with 10 instead of 11, it'd be wrong, because you'd only, if it were 10, it'd end up being a 9 over here, which is not 10 years worth of growth. So that's what pick up on. Part B, this is where you realize you're just looking for two missing numbers, first term common difference. You realize this thing over here, right, it's unrelated to the first parts. The only other thing you can make this equal to, because if you don't start off with something equals to something, you're not going to be able to solve for two missing numbers. That's just, no matter what type of question you're doing, if you're looking for missing numbers, you need the equal symbol. There's no equal symbol right now. The only way you could set up something with an equal symbol being involved with this is making this equal to what? MF19 formula sheet, there's a formula for this. The sum to n terms is applicable to this, isn't it? This is equal to that sum to n terms formula on the formula sheets. Sum of n terms for arithmetic, make it equal to that. When you have this, you don't need to be told to simplify this to expand. Expands. Expand. And what we're doing over here is, the reason why we factorize these is just based on the principle that if you have, say, separate example, really basic one, an squared plus 2 equals to 3n squared plus c. Isn't it really obvious that a has to equal to 3, 2 is equal to c? It's mix and matching, isn't it? If you have ax squared plus 2x plus 9 equals to 4x squared plus ax plus b, excuse me, plus c, isn't that just b is equal to 2, c is equal to 9, a is equal to 4? Because when you have left hand and right hand side are equal, and they're really similar formats, aren't they? You can just mix and match. Just combine them to find the missing numbers. Same principle over here. You can see how this works. You can see it's going more and more like that basic principle, isn't it? And you understand, because on the left hand side there's only one thing involving n, right hand side there's two things involving an n, but you know you can combine them, can't you, from factorization principles like this, brackets. N times what becomes an, or a. N times what becomes minus d n over 2 is minus d over 2. And you can tell, oh shit, d over 2 must be 3 over 2 then. Because this is the only thing on the right hand side with n squared, this is the only thing on the left hand side with n squared. If they're equal, which you know they are, common sense tells you this has to be the same, which you work out d is equal to 3. A minus d over 2 is now a minus 3 over 2. Why would you leave that as d when you already know what d is? More detailed, better, right? This times n has to equal to this thing times n. Oh, 7 over 2 is the number in front of n. This is the number in front of n, equals to 7 over 2. Which we can move this to the other side to get a is equal to 5.